Imagine you are standing in a dark room, trying to find a massive, black marble hidden somewhere in the corners. You can't see the marble itself, but you notice that the dust on the floor is swirling in a very specific pattern, and the smaller marbles you've already found are being pulled toward an invisible point in the shadows. For over 100 years, astronomers have had a nagging feeling that something massive is lurking at the very edge of our solar system, far beyond the orbit of Neptune and the icy plains of Pluto. We call it Planet 9. A hypothetical giant that is so distant it takes nearly 20,000 years to complete a single trip around the Sun. But just recently, a series of breakthrough observations and gravitational simulations have provided the most compelling evidence yet that this ghost world is not just a myth. It is out there. It is likely 5 to 10 times more massive than Earth, and it is currently tugging on everything in its neighborhood with a gravitational authority that we can no longer ignore. This discovery is being hailed as the most significant update to our celestial map in over a century, and it changes everything we thought we knew about how our solar system was formed. Today, we are diving into the incredible hunt for the ninth planet, the recent scientific discoveries that have pinpointed its location, and why this hidden giant might be the most important key to understanding our place in the cosmos. To understand why we think there is a hidden planet, we have to look at the misfits of our solar system. Beyond Neptune lies the Kuiper Belt, a vast, frozen ring of icy objects and dwarf planets. Most of these objects orbit the Sun in a relatively predictable way, but a small group of them, known as extreme trans-Neptunian objects, are doing something extremely weird. Instead of being spread out randomly, their orbits are all clustered together, pointing in the same direction and tilted at the same strange angle. The mathematical probability of this happening by chance is less than 0.007%. It's like looking at 1,000 clocks and noticing that every single one of them has stopped at exactly the same second. Something is hurting these icy rocks. Something with immense gravitational power is acting like a cosmic shepherd, keeping these objects in a very specific, elongated pen. The search for Planet 9 isn't just a modern obsession. It actually goes back to the discovery of Neptune in 1846. Back then, astronomers noticed that Uranus wasn't moving the way it should. It was being pulled by an invisible force. Using nothing but math and a pencil, they predicted exactly where another planet should be, pointed their telescopes, and found Neptune. After that, the hunt for Planet X began. Percival Lowell spent his life looking for it, which eventually led to the discovery of Pluto in 1930. But Pluto was too small. It didn't have enough mass to explain the wobbles in the outer solar system. For decades, the search went cold, until Mike Brown and Konstantin Batygin at Caltech released a groundbreaking paper in 2016 that used advanced supercomputer simulations to show that only a massive, distant planet could explain the chaotic orbits we see in the Kuiper Belt. Since that paper, the hunt has gone into overdrive. But finding Planet 9 is a technological nightmare. Because it is so far away, it reflects almost no light from the Sun. It is essentially a dark object moving against a background of billions of much brighter stars. It's like trying to find a black cat in a coal cellar while someone is shining a flashlight in your eyes. However, recent scientific discoveries using the Pan-STARRS Sky Survey and the Subaru telescope in Hawaii have allowed researchers to narrow down the search area to a specific patch of the sky in the northern hemisphere. They are looking for a moving dot that moves just a tiny bit every year. What would Planet 9 actually look like? If it is 10 times the mass of Earth, it is likely a super-Earth or a mini-Neptune. This is a type of planet that is incredibly common in other solar systems but was strangely missing from ours. It would probably have a thick, gaseous atmosphere made of hydrogen and helium, wrapped around a rocky core. Because it is so far from the Sun, the temperatures on the surface would be unimaginably cold, perhaps making it a world of frozen neon and liquid methane. But the most interesting part is its internal heat. A planet that large remains warm on the inside for billions of years. This means Planet 9 might have its own moons, and those moons could be heated by tidal forces, potentially creating hidden subsurface oceans of liquid water far away from any sunlight. The discovery of a super-Earth in our own backyard would force us to rewrite every textbook on planetary evolution. For a long time, we thought our solar system was the standard model: small rocky planets near the Sun and giant gas planets further out. But most of the thousands of exoplanets we've discovered around other stars are super-Earths. If we find that we have one too, it means our solar system isn't a weird outlier. It means we fit the universal norm. But it also raises the question, where has it been hiding? Some theorists suggest that Planet 9 didn't start out in its current location. They believe it was born closer to Jupiter and Saturn and was kicked out to the fringes during a period of gravitational chaos billions of years ago. It's a celestial exile, a planet that was nearly thrown away but managed to hang on to a distant, lonely orbit. But there is an even more radical theory gaining steam in the scientific community. Some researchers, like James Unwin and Jakub Schultz, have suggested that Planet 9 might not be a planet at all. They believe it could be a primordial black hole, a tiny, dense remnant from the Big Bang no bigger than a bowling ball, but with the mass of 10 Earths. This would explain why we haven't seen any light from it. If it's a black hole, it wouldn't reflect any sunlight. It would only interact with the world through gravity. While this sounds like science fiction, it fits the mathematical models perfectly. To test this, scientists are looking for microlensing events, where the gravity of this invisible object warps the light of distant stars behind it. The impact of finding Planet 9, whether it's a planet or a black hole, cannot be overstated. It would be the first major planet discovered in our solar system since the 19th century. It would give us a lab to study the most common type of planet in the galaxy without having to travel light years away. We could send a probe, although with current technology, it would take 50 to 75 years to get there. But imagine the images. A dark, shimmering world of ice and gas, orbiting in a realm where the sun is just another bright star in the sky. It would be the ultimate frontier. Recent scientific discoveries involving the Dark Energy Survey have also helped eliminate areas where Planet 9 is definitely not located. This process of elimination is just as important as the search itself. By checking off large portions of the sky, astronomers are focusing their resources on the most likely hiding spots. We are currently waiting for the Vera C. Rubin Observatory in Chile to come online. This telescope is designed to map the entire visible sky every few nights with a 3,000-megapixel camera. If Planet 9 is out there, the Rubin Observatory will find it. It will see that tiny, slow-moving dot that every other telescope has missed. But why should we care about a cold, dark planet billions of miles away? Because Planet 9 is the keystone of our solar system. Its gravity affects the tilt of the sun and the stability of the inner planets. Some researchers even believe that Planet 9's long, eccentric orbit might occasionally bump comets out of the Oort cloud and send them tumbling toward the inner solar system. This could mean that this hidden planet has played a role in the history of life on Earth, occasionally influencing the rate of comet impacts over millions of years. It's a silent guardian, or a silent threat, that has been influencing our world from the shadows since the beginning. The mathematical precision required for these Batygin and Brown simulations is staggering. They had to account for the gravity of all 8 known planets and thousands of smaller objects. When they added a 9th planet with a specific mass and orbit, the chaotic Kuiper belt suddenly made perfect sense. The clustering of the objects wasn't a mystery anymore. It was a physical necessity. It's like finding the missing piece of a jigsaw puzzle that makes the whole picture clear. The math is telling us that Planet 9 is real, even if our eyes haven't caught up yet. There is also a fascinating international competition happening. Teams from the United States, Japan, and Europe are all racing to be the first to capture an image of the new world. This space race is driving theater-level innovation in image processing and telescope design. For example, astronomers are using stacking techniques, where they take thousands of long-exposure photos of the same patch of sky and layer them on top of each other to find objects that are too faint to see in a single shot. This is how we found some of the smallest moons of Jupiter, and it's likely how we will finally see Planet 9. If the planet is eventually found, the debate over its name will be legendary. Some want to keep the Roman mythology theme, perhaps naming it Erebus, after the god of darkness, or Proserpina, the queen of the underworld. Others want to name it after the pioneers who predicted its existence. But regardless of the name, it will signify a new era of exploration. We are realizing that our backyard is much larger than we thought. The space between Neptune and the nearest star isn't just empty darkness. It is a complex, populated landscape of worlds we are only just beginning to name. Let's talk about the super-Earth aspect for a moment, because this is the real scientific goldmine. Super-Earths are planets with a mass between that of Earth and Neptune. We don't have one in the traditional 8-planet model, which has always been a mystery to astronomers. Why would our solar system be missing the most common type of planet in the universe? Finding Planet 9 would solve this missing mass problem. It would mean our solar system is a perfect representative of the galactic average. We would finally have a way to understand the atmosphere, the geology, and the potential for life on the most common type of world in the universe. The internal structure of Planet 9 would also tell us about the early days of our Sun. If it was indeed kicked out of the inner solar system, its chemical composition would be a fossilized record of the nebula that formed the planets. By studying its gas, we could learn exactly what the solar system was made of 4.5 billion years ago. It's a time capsule with the mass of 10 Earths preserved in the deep freeze of interstellar space. The search has also led to the discovery of hundreds of other minor planets and Kuiper Belt objects that we never knew existed. Even if we never find Planet 9, the search itself is mapping the outer reaches of our world in unprecedented detail. We have found goblins and far, far outs, objects so distant they make Pluto look close. Each of these finds is a tiny clue that helps refine the orbital path of the giant we are looking for. It's like following a trail of breadcrumbs through a forest to find a hidden castle. Some skeptics argue that we don't need a planet to explain the clustering of the Kuiper Belt. They suggest that the collective gravity of all the small icy rocks could do the trick if there were enough of them. This is the self-gravitating disk theory. But current estimates of the total mass of the Kuiper Belt show that there isn't nearly enough material to pull it off. You would need 20 times more material than we've observed. This makes the single giant planet theory much more plausible. The math simply leans toward a single massive body rather than a million tiny ones. Everything about Planet 9 is on a scale that is hard to imagine. Its orbit is so large that it doesn't even stay in the same plane as the other planets. It's tilted by 30 degrees, cruising high above and then deep below the rest of the solar system. This tilted orbit is one of the strongest pieces of evidence for its existence, as it explains why the Sun itself appears to be tilted by 6 degrees. Planet 9's gravity has been slowly yanking on the Sun for billions of years, causing the whole solar system to wobble ever so slightly. If we look at the history of science, we see that we are often wrong about the size of our world. We used to think the Earth was the center. Then we thought the Sun was the center of everything. Then we thought galaxies were just nebulae inside our own galaxy. Every time we think we've reached the edge, we find that the world is bigger and more complex. Planet 9 is just the next step in that journey. It is a reminder that we are still explorers, and that there are still giants waiting to be found in the dark. The technical specifications of the Vera Rubin Observatory are particularly interesting for people who love recent scientific discoveries. It features an 8.4-meter primary mirror and a camera the size of a small car. It will generate 20 terabytes of data every single night. To process this, scientists are using deep learning AI that can scan the images from moving objects faster than any human could. This is the first time in history that a planet discovery will likely be made by an algorithm first, and then confirmed by a human eye. We are using the most advanced machine minds to find the most ancient celestial bodies. We also have to consider the star capture theory. Some researchers, including those at Harvard, have proposed that Planet 9 might not have been born in our solar system at all. They believe it might be an exoplanet that our Sun stole from a passing star billions of years ago. Our Sun was born in a crowded cluster of stars, and interstellar theft was likely very common during that time. If Planet 9 is an alien world that was captured by our Sun, it would be the first time we've ever had a piece of another solar system within our reach. We would be able to study the chemistry of a different star system right here at home. The discovery would also have huge implications for the private space industry. Companies like SpaceX and Blue Origin are already looking at high-speed ion thrusters and nuclear thermal propulsion. Finding a massive target at the edge of the solar system would provide the ultimate destination for these technologies. It would give us a reason to build ships that can travel at significant fractions of the speed of light. Planet 9 would be the Pluto of the 21st century, a world that captures the public's imagination and drives us to go further and faster than ever before. As we look at the heat map of the sky where Planet 9 is expected to be, it's a game of patience. We have to wait for the planet to move enough to be distinguished from the stationary stars. Because its orbit is so long, it only moves a few arcseconds per year. It's the ultimate turtle of the solar system. But every month, we get a little more certain. Every month, the shepherding of the Kuiper Belt objects is confirmed by new data from telescopes like the Dark Energy Camera. The evidence is building like a crescendo, and we are nearing the finale. It's also interesting to think about the shadow zone of the Sun. There is a region of space where the Sun's gravity and the gravity of the galaxy are in a delicate balance. This is where Planet 9 resides. It is the frontier where the Sun's influence starts to fade into the interstellar void. Finding a planet here would tell us about the boundary conditions of our solar system. It would show us exactly how far the Sun's grip can reach. The search for Planet 9 is a testament to the power of human curiosity. We aren't looking for it because it's easy, or because there is an immediate profit. We are looking for it because we want to know what home really looks like. We want a complete map of our neighborhood. For the thousands of years that humans have looked at the stars, we've always wondered what lay beyond the horizon. For the first time, we have the tools to actually go and find out. The mini-Neptune hypothesis suggests that Planet 9 might have rings, similar to all the other giant planets in our system. Imagine a massive, dark world with a subtle ring of ice and dust, orbiting in the eternal twilight of the outer solar system. It would be a hauntingly beautiful sight. If it has a thin atmosphere of nitrogen and methane, there might even be clouds or weather occurring at temperatures of -400 degrees Fahrenheit. It would be a laboratory for extremophile chemistry, where the rules of gases and liquids are completely different from what we experience on Earth. Let's consider the orbital resonance that makes this discovery possible. Planet 9 isn't just pulling on the Kuiper Belt objects. It's in a dance with them. They have been locked into these specific paths over billions of years. This resonance acts like a fingerprint. By studying the orbits of the 6 most distant objects, Atigan and Brown were able to calculate not just the mass of Planet 9, but its exact orientation in space. It's like hearing a symphony and being able to tell exactly where the missing violin is sitting, even if you can't see the performer. The Subaru telescope has already spent dozens of nights scanning the most likely region of the sky. While they haven't announced a discovery yet, they have successfully narrowed down the brightness of Planet 9. We now know it is likely magnitude 22 or fainter. This is millions of times dimmer than the faintest star you can see with the naked eye. This upper limit on brightness helps determine the size and reflectivity of the planet. It's another piece of the puzzle that brings us closer to the truth. One of the most exciting recent scientific discoveries is the finding of a new extreme trans-Neptunian object every few months. Each one of these provides a new data point for the simulations. So far, every single new object found has fit the Planet 9 model. If the planet didn't exist, we would expect to see objects with random orbits. The fact that they all line up like soldiers on a parade ground is the smoking gun that keeps the scientific community convinced. The discovery would also solve the tilted sun mystery that has puzzled astronomers for 50 years. All the planets orbit in a flat plane except the sun, which is tilted by 6 degrees. For decades, we had no idea why. We thought maybe a passing star had pulled the sun, or maybe it was an internal magnetic effect. But if a massive planet is orbiting on a tilted path far away, its gravitational torque over billions of years would naturally pull the whole solar system out of alignment. It turns out the sun isn't tilted, the planets are. We've been living in a solar system that is being slowly leaned over by an invisible giant. The quest for Planet 9 is also a story of data mining. Astronomers are going back through old telescopic data from the 90s and 2000s, looking for that one pixel that moved. They are using modern software to reanalyze images that were taken for completely different purposes. It's like going through old family photos and realizing that a stranger has been in the background of every shot for 20 years. Planet 9 has been in our photos, we just weren't looking for it. As we conclude this journey to the edge of the solar system, let's take a moment to appreciate the sheer persistence of science. From the pencils of 1846 to the supercomputers of 2024, the hunt for the outer worlds is a multi-generational effort. We are close. We are closer than we've ever been. The Vera Rubin Observatory will likely give us the final answer within the next few years. Imagine the headlines when it finally happens. 9th planet found. It will be a moment that unites the world in wonder. It will be the Pluto moment for a new generation. We will realize that the map of our home was never finished. There was always one more room, one more giant, one more mystery waiting in the dark. Everything we've learned from the recent scientific discoveries tells us that our solar system is a dynamic, changing place. It isn't just a static clockwork machine. It's a place of history, exile, and hidden power. Planet 9 is the symbol of that hidden world. It is a massive, cold, beautiful giant that has been watching us from the edge of the void for 5 billion years. It's also a reminder that the universe is under no obligation to be easy to see. Most of the matter in the universe is dark, and most of the worlds are hidden. But we as a species are under an obligation to keep looking. It's what we do. We build bigger lenses, faster computers, and better theories until the invisible becomes visible. So the next time you look at a model of the solar system with its 8 neat planets, remember that there is likely a 9th. A huge, dark world cruising through the Oort cloud, pulling on the strings of the sun and shepherding a fleet of icy comets. Remember that there is a giant hiding in the dark, and we are just about to find him. The lighthouses of our telescopes are sweeping the sky, looking for that one moving speck. The math is waiting, the simulations are running, and Planet 9 is out there, waiting in the silence. It's a new planet in our own solar system, and it could be bigger than Earth. This is the era of discovery, and the best part is that we get to see it happen in real time. Recent scientific discoveries are making the universe feel smaller and more accessible, but they also remind us of its incredible scale and complexity. Planet 9 is the ultimate bridge between the known and the unknown. It is our neighbor, but it is an alien. It is part of our family, but we've never met. Soon, the hunt will be over. The dot will be found. The coordinate will be fixed, and humanity will have a new world to dream about. We will have a new place to wonder. Are there moons? Is there water? What does it look like when the sun is just a bright star in a purple sky? The ninth planet is out there. It's larger than Earth, it's cold, and it's been waiting 13 billion miles away. The story of our solar system is getting a new chapter, and it is going to be the most exciting one yet. Keep your eyes on the stars, and your ears open for the next big reveal from the world of recent scientific discoveries. The universe is full of secrets, and we are just getting started on finding them all. Thank you for exploring this hidden frontier with me. The world is a vast place, but the solar system is vaster, and every new planet we find makes it feel just a little bit more like home. Stay curious, stay informed, and never lose that sense of wonder that makes us look up at the night sky and ask, what else is out there? Planet 9 is waiting. Let's find it together. Until next time, stay inspired by the incredible scale of the cosmos.